This next section is going to circle back to the first thing we learned about integrals, that the main idea of an integral is it gives you the area under the curve. So we're not going to do any actual mathematical calculations in this part. We're just going to be calculating the area under the curve and adding the different areas together. So I want you to remember that if it's underneath an x-axis, then it's a negative area, and if it's above an x-axis, it's a positive area. So even though in this problem it gave you the areas that are all positive, technically area A is negative, and area B is positive, area C is negative. So when we start to evaluate some of these integrals, you can see that. So for part A, it wants us to find the integral from A to B of f of x dx. So that means we're going to find the area from this point all the way to this point. So we're going to add all those areas together. So we're going to add area A plus area B. Well, area A is negative 2.33 and area B is 10.67. And we can simplify that to be 8.34. So let's look at the next one. Now we're going from A to C. So it wants to know all the way from here to here. So I'm going to add all three areas together. I'm going to add the negative 2.33 plus 10.67 plus your negative 5.63. And we can combine all of those. And when you type that into your calculator, you get 2.71. This last one I need you to change a little bit. I meant to put a 0 there at the bottom, otherwise it's the same question as you had before. So we're going to change this A to be a 0 and then calculate the integral here. So from 0 to C is adding up the areas B and C together. So that's going to be 10.67 plus the negative 5.63. So when we type that into our calculator, we get 5.04 as the area. So let's take a look at some other examples and some properties of definite integrals. The first one is when the bottom part of your integral and the top part of your integral are the same, then the integral is just going to be 0. Think of it as if you were doing f of 0, or maybe not even f of 0. If you did like f of 8 minus f of 8, those would cancel each other out, so it's going to equal 0. The second one is if you're going from A to B, but you want it to go from B to A, so remember they have to go from lowest to highest, you can switch these around. You can switch your integral limits going from B to A if you make it negative. And I'll show you an example. Let's say it was from 3 to 2. Well, you can't write it like 3 to 2, that's improper, so you have to rewrite it as negative 2 to 3. You can rewrite it like that. The next one is if you've got a constant, you can take the constant out of your integral, just like we've been doing, and then at the very end multiply by the constant. So evaluate the whole integral all the way through, and then at the very end multiply by that constant. And then you can also split your integral up when you're adding and subtracting. So you can break this apart to be f of x has its own integral, and then either adding or subtracting, and then g of x has its own integral. So you can work out those integrals separately. And then finally, if you've got a very large interval, you can break it up into smaller intervals. So let's say there's some b inside A to C. I could break this up. I could do the integral from A to B first, and then do the other half of the integral from B to C, f of x dx. So sometimes it's helpful to break apart an integral into smaller intervals to help you solve. So let's look at a couple examples of how to apply these properties. In this example, they already gave you the value of 3 different integrals. So you just have to be able to pick out which one you're going to use and then use some of the properties. So part A, I see that I'm doing the integral from 0 to 2 of 12x squared. Well, I see the x squared part matches one of my integrals from above. So what I'm going to do is take out the 12, and then I've got the integral from 0 to 2 of x squared dx. Well, the integral of x squared from 0 to 2 is 8/3. So I've got 12 times 8/3, which is 32 when you type it in the calculator. So all I did there was I took this part right here and matched it up with this and substituted the 8/3 instead. For part B, I have 2 different things I'm subtracting. So I'm going to break it apart. I've got from 0 to 2 of 2x, I'm going to take the constant out, minus 0 to 2 of 6x squared. And so I can evaluate this integral using the stuff above and this one from the stuff above. So I've got 2 times 2 minus 6 times 8/3. So we've got 4 minus 16, which is -12. So now let's look at part C. Right now, the first thing I notice is that it goes from 3 to 2 instead of 2 to 3. So I need to rewrite that. And when you flip the intervals, you have to go put it negative. So I have negative from 2 to 3, x squared dx. Well, the integral of x squared from 2 to 3 is 19/3, so I have -19/3. That's your final answer. These last two are a little bit tricky. So for part D, it goes from 5 to 5. Well, the property for integrals, when it's the same on the bottom and the top, is it just equals 0. So I have 3 from 5 to 5 of x squared dx. Well, that's just 3 times 0, which is 0. And part E, you've got from 0 to 3. Well, none of my integrals at the top go from 0 to 3. So I am going to break it apart between 0 to 2, this one, and 2 to 3. So I'm going to go from 0 to 2, 3x squared, and then from 2 to 3, 3x squared. And then I'm going to take out the constants, 3 from 0 to 2, x squared dx, plus 3 from 2 to 3, x squared dx. And so the last thing I'm going to do is the integral of x squared from 0 to 2 is going to be 8/3. So we've got 3 times 8/3 plus 3 times 19/3, which is 8 plus 19, which equals 27. So your homework for today is going to be applying these properties and doing examples like the ones we just learned. I'm also going to add in some more examples and more practice problems of what you learned in our last lesson so that you can continue practicing them. Next week, we're going to start doing U substitution again. So if you need to brush up on U substitution, please go back and watch those videos. And as always, I'm available during my office hours if you have questions. Bye, guys. I hope you have a great day.